Though NASA has made various trips to space in the hope of finding life beyond Earth, and in search of that, they found various things. And today, we are showing you something terrifying, and scientists are speculating this massive thing is changing our solar system. There are numerous rocks surrounding our solar system, but this time, this thing is at the edge of our solar system. The object is close to being detected by the Earth's machines, which is surprising and terrifying at the same time. Let's find out about that thing. Here we begin. Our solar system is only a speck in the vastness of the universe. From the depth provided by James Webb's first images to the journeys taken by Voyager 1 and Voyager 2 into interstellar space, our universe is much larger than our solar system's edge. Scientists have recently discovered a series of terrifying changes in heliopause, the boundary between our solar system and interstellar space. The heliopause is our solar system's outermost boundary, and as such, it serves as the final barrier between our solar system and that of the interstellar medium. As a result, changes in heliopause have always piqued scientists' interest. However, newly discovered data indicates some frightening changes that our current models of heliopause cannot explain. The changes were discovered while reviewing NASA's Interstellar Boundary Explorer or IBEX data. According to Space.com, the satellite captured several brightening energetic neutral atoms or ENAs that indicated a lack of symmetry in the heliopause. Furthermore, they discovered changes in the heliopause while reviewing data from Voyager 1 as well as Voyager 2. The scientists also discovered that the changes in the heliopause caused by Voyager 1 and Voyager 2 entering interstellar space were so dramatic that they defied current models of our solar system's boundary point. These drastic changes may also explain why the two probes enter the interstellar medium with such a large gap. Earlier this month, researchers published a paper on the subject in the journal Nature Astronomy. They described the changes in the heliopause as potentially controversial. They also intend to continue investigating the outer reaches of our solar system, employing NASA's Interstellar Mapping and Acceleration Probe to better understand these changes. Scientists will have to rely on spacecraft like the Voyager probes and current data to learn more about interstellar space until then. Space echolocation. IBEX detects energy-charged neutral atoms when the sun-solar wind collides with the interstellar wind at our solar system's boundary. Some of these atoms are ejected into interstellar space, while others return to Earth. These particles can further be used to map the border shape. This principle is similar to that of space echolocation. Previous heliospheric structure maps were based on long-scale measurements of the evolution of solar wind pressure and emissions of energetic neutral atoms, which resulted in smoothing the boundary in space and time. However, the dynamic pressure of the solar wind increased by about 50% in 2014 for about 6 months. A team of scientists led by Princeton University astrophysicist Eric Zernstein used this event to obtain a highly detailed photograph of the shape of the boundary of the shockwave in the heliopause and discovered a massive ripple on the scale of tenths of astronomical units or AU. They also ran simulations to see how this high-pressure solar wind interacts with the solar system's boundary. They discovered in 2015 that a pressure wave formed between the shockwave limit and the heliopause. The reflected wave returns to the heliopause, colliding with a stream of charged plasma, causing a storm of energetic neutral atoms to fill the inner helium shell, causing ripples in its shell. Swollen heliopause. The distance to the heliopause is also shifted significantly according to measurements. In 2012, Voyager 1 passed through the heliopause at a distance of 122 astronomical units. According to the team, the heliopause had swollen because the distance between it and Voyager 1 was already around 131 astronomical units. Moreover, measurements show that the shape of the heliopause changes with time, but no one knows why. To find out, NASA will launch a new probe in 2025 to measure the study of energetic neutral atoms with greater accuracy and over a wider range of energies. According to scientists, this should help clarify some of the mysteries surrounding the amazing wrinkled bubble that shields our small planetary system from space radiation. Earlier, there was yet another discovery when Hubble detected ghostly glow surrounding our solar system. The nighttime sky appears inky black to the casual observer, apart from a tapestry of glittering stars and the glow of the waxing and waning moon. But just how dark is it? In an ambitious project called SkySurf, astronomers decided to sort through 200,000 of images from NASA's Hubble Space Telescope and make tens of thousands of measurements on these images to look for any residual background glow appearing in the sky. This would be any remaining light after subtracting the glow from planets, stars, galaxies, and dust in our solar system's plane called zodiacal light. When the researchers finished their inventory, they discovered an extremely small excess of light, equivalent to the constant glow of 10 fireflies spread across the entire sky. That's like turning off all the lights in the darkened room only to discover an eerie glow emanating from the walls, ceiling, and floor. According to the researchers, one possible explanation for this residual glow is that our inner area of the solar system contains a teeniest sphere of dust from comets falling into our solar system from all directions, and that the glow is sunlight reflecting off this dust. If confirmed, the dust shell discovered could be a new addition to the solar system's known architecture. This theory is supported by the theory that in 2021, another team of astronomers measured the sky background using data from NASA's New Horizons spacecraft. New Horizons flew by Pluto in 2015 and a small Kuiper Belt object in 2018 before entering interstellar space. The measurements were taken by New Horizons at a distance of around 4 billion to 5 billion miles from the Sun. This is far beyond the realm of planets and asteroids, where there is no interplanetary dust contamination. New Horizons detected something fainter that appears to be from a more distant source than Hubble. The source of the background light observed by New Horizons is also unknown. Numerous theories range from dark matter decay to a massive unseen population of distant galaxies. If our calculations are correct, there is another dust component between us and the distance measured by New Horizons. That means this is extra light coming from within our solar system, Tim Carlton of Arizona State University stated. Because our residual light measurement is higher than New Horizons, we believe it is a local phenomenon not far beyond the solar system. It could be a new component of the solar system's contents that has been hypothesized but not quantitatively measured until now, Carlton stated. Roger Windhorst, also of ASU, came up with the idea of assembling Hubble data to look for any ghost light. More than 95% of the photos in Hubble's archive come from less than 3 billion miles away from Earth. Since Hubble's early days, most users have ignored these sky photons, preferring to focus on the faint discrete objects in the images by Hubble, such as stars and galaxies, Windhorst stated. However, these sky photons contain important information that can be extracted thanks to Hubble's distinct ability to measure faint brightness levels with high precision over the course of its 3 decades of life. SkySurf was developed by a number of graduate and undergraduate students, including Sarah Caddy at Macquarie University in Australia, DeLandre Carter, Rosalie O'Brien, and Darby Kramer at ASU, Scott Tompkins at the University of Western Australia, and many others. The Hubble Space Telescope is a NASA-ESA international collaboration project. The telescope is managed by NASA's Goddard Space Flight Center in Greenbelt, Maryland. Hubble and Webb Science operations are managed by the Space Telescope Science Institute in Baltimore, Maryland. Also, the Association of Universities for Research in Astronomy in Washington, D.C. operates STSCL for NASA. What do you think of these discoveries by NASA? Isn't it terrifying? Comment your views in the comments section below and make sure to subscribe for more such videos.